Excellent. So good afternoon, everybody. Happy Thursday. I hope you're in a good mood. I know I am. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And leading the webinar today is Paul Dye, who is a solutions consultant and applications engineer with the Virtual Center of Excellence with PTC. And I will say that Paul is one of those people that does exude excellence. He's done a lot of webinars for us, and he does a great job every single time. So, Paul, thanks a lot for leading the webinar today, which is going to focus on the geometric dimensioning and tolerancing extension that works with PTC Creo. So Paul's going to give an overview of a little bit more about model-based definition and the GD&T extension. And if you have any questions, pop those into the chat box. We will try to answer them as we go along, but we'll definitely answer them at the end. So Paul, you have control. Let's rock and roll.
All right, perfect. Thank you very much, Rob, for having me on, and
Always.
really happy to go through today to talk around this. This is a pretty big area of interest. It seems like every single year that I've been working with it, more and more people are starting to learn into it, adopt it, and starting to roll it out in their companies, and really just trying to improve what we're doing at the end of the day for our manufacturing documentation. So there's two sides to this I'm going to touch on today, really the first of which being the base for what we're going to go over, which is model-based definition. I'll go through and talk to that, and then we'll spend the second half of this going over the GD&T Advisor, which is really helping us work in the area of model-based definition and giving us guidance and ensuring and validating that we're doing the correct work as well. So around this, there's a lot of information. So if you have any questions, feel free to drop those in the chat. I'll be more than happy to answer anything in that. If there's anything that I can answer today, I'll be able to reach back out and get pretty much anything that you might need answered. So happy to go through any of that. So without further ado, I can go ahead and jump into it here. And first things first, I want to go over some of the main challenges that we see out in the industry. And first and foremost, I want to talk about the challenges of 2D drawings. Now, 2D drawings have traditionally been the primary way that we have of transferring design information that we have in 3D modeling, for example, out into the manufacturing world. It's the way that companies have always done this type of work, but the process that you do over in 2D has inherent issues that you can't really ignore. In order to use 2D to describe something that's going to be created in 3D space, you have to use a series of complicated drawings that are difficult to read, difficult to interpret the design intent of the model, and oftentimes it's a very manual and error-prone way of operating. It even seems from talking with different companies that reading these types of drawing is a skill that seems to be dying off more and more every year. And if you have any misinterpretation of the drawings that you're creating, that leads to delays, leads to rework that we really need to be avoiding there as well. And this is all compounded by the fact that we're oftentimes going to have changes happening to the source 3D model that you're working with. When those changes happen, you need to make sure that those changes have been properly pushed to all of your 2D drawings that you've done and done so in a manner that hasn't changed the intended design intent and overall output that you're looking to get to. So what we really look to do is start to work with model-based definition as a way of really giving us solution to a lot of these different problems. But even with model-based definition out in industry, we've seen that those can be cumbersome as well. You just simply aren't able to add in the detail or the dimensions that you really need, everything that you would typically include on a 2D drawing. And if you are able to, it can be difficult. We've seen a general lack of support now in the industry whenever it comes to 3D annotations. A lot of companies have standards and rules that they need to follow, and they also need to make sure that their manufacturing documentations, including all that. You need to also make sure that the people that are manufacturing our designs, the people out on the shop floor, that they're able to support any of the work that's being done on the 3D side. Because it's great if you could have all your dimensions and tolerances all defined from the 3D model, but if your shop isn't able to take that in and make use of the information, what do you really have at that point? And lastly, the other thing we see is just a general resistance to process change. 2D drawings have pretty much always been a part of the process, and teams don't want to go through a painful conversion process to reach a state where all their information is ultimately defined from a 3D model. But that is what we would really look to do here with Creo, and we've taken all those challenges into consideration, and what we've done is build out tools specifically in Creo and using model-based definition to allow you to create 3D models that contain all that data, and making sure that at the end of the day, it's all correct. It's all gone through and you've defined everything that you need to, and then it's ultimately easily utilized by your downstream consumers of the data. And this is, of course, going to start with your full 3D annotations that you're building out. Within Creo, you have a robust set of tools that allow you to go through and very quickly, very easily create and edit all the annotations that would have traditionally existed on the 2D model. So that includes things like dimensions, tolerances, datum features, nodes. All that can now be very easily defined right on the model itself. You don't have to switch over to a drawing to go through and define all of that. And the other thing this allows us to do is work with combination states in Creo. This is going to be a key aspect of how we can create more clear, concise annotations. So working with combination states in Creo allow you to view a model in different states, could be different orientations, even just different appearances, that allow us to group and define different annotations into a much more clean and really easy to use format as well. So what we're moving away from is having hard to read 2D drawings that have hundreds of different annotations all crammed together under the same model. We now have that 3D model that we can utilize in different states to better organize really the functional intent of those annotations. We also have symbols that are another very key component to how we define all that. So we work in a streamlined user interface for placing all those in, and I can show a little bit about what that looks like as well. Now, looking at the tools specifically that we're going to use to help this, Model Check is a very powerful tool that we can utilize during the process to help ensure that all your standards and modeling practices are followed. This is just some out-of-the-box capabilities that you're able to work with, help people get up to speed with model-based definition. Also working around standards and compliance, anything that we're building out, whether it be ASME or ISO standards they have to follow, we got you covered in that sense. And really ultimately what we're looking to do is you do all this to define our digital thread for our products, really looking to have a closed loop between the physical products that you have out in the real world and then all the digital information that we're defining those products with as well. Now, everything that I've discussed so far has really been more so core capabilities of what we work with around Creo Parametric to help us build out model-based definition in the first place. But what we really want to go through and do is give you specific tools and extensions that are going to enable you to do even more in this process. So probably the strongest tool that we have in this regard is the GD&T Advisor. And I'm going to go through and show exactly what this looks like. But the idea with this tool is that we're giving expert guidance on the application of your geometric dimensions and tolerances, as well as validation that it's all been done correctly. So again, I'll show an example of what this looks like. But if you were to go through and apply a tolerance normally without this extension, you would have all the different options available to you, and it's up to you, the user, to figure out what's going to be best, understanding what's constrained and unconstrained. But what the advisor is doing for you now is, say you were going to apply a certain tolerance, it would give you suggestions based off of that part or the feature that you selected. And it's also not going to give you options to apply a tolerance if it would be invalid for that feature. So it's helping also to educate the users, to give you context into any of the advice that you're receiving. So it's making sure that at the end of the day, you're only putting in the information that you need, and then what you're putting in is also going to be correct at the end of the day. So very powerful tool that I'm going to go through and show as well. A couple other tools that we work with along this process as well that you want to be aware of is a tool called the Easy Tolerance Analysis extension as well. This is more so for evaluating the impact of the tolerances and the dimensions that you put into your designs. So this is what we would do for what you might think of for 1D or 3D stack ups, where you're able to go through and work with this well before something like a product would ever go out for prototyping or manufacturing. And we're able to take 3D annotations that you're building out, and you can look into different statistical results, look for potential defects, worst case scenarios, even understanding which of your tolerances are having the highest contribution to the goals that you lay out for the model. So a very powerful tool that we have working around model-based definition for doing tolerance analysis. And then also a tool that you may have heard of before called Creo View. So this is, again, our way of taking the 3D models that we're building out with those annotations and giving it to your users downstream to be able to view. It's a free to use visualization and markup tool. Anyone throughout your organization is able to work with there as well. All right, so what I'm going to do now is switch over into the Creo environment so we can see what some of these different tools look like. I'm going to go through first and foremost and do some model-based definition work so you can see what it looks like to first and foremost build out 3D annotations. And then we'll take the second half to switch over into the GD&T Advisor to gain some guidance, to gain some education around the process, and look what it really looks like to do validation work on that model-based definition. So again, if you have any questions, feel free to drop those in. We could touch on those towards the end, but hopefully this will help to give a little bit of perspective on the process, and you can really see what it looks like to lay these things out on the 3D models themselves. All right, so here's the model that we're going to be working with. This is going to be, again, focusing more so on the model-based definition portion of this first, and then we'll switch over to the advisor portion after that. So here we're going to be starting off with our gripper link design. And this might be something that we're going through and sending out for production. So I'm going to start off in our annotate mode. This is a mode that keeps all the different sets of annotations grouped together into a clean, easy to use environment. So first thing I'll do is use our geometric tolerance button. Say you want to apply one of these GTOLs to our top surface here. It's just as easy as clicking on the area that you want to apply it, dragging it out so you can see it. And from there, you'll set the geometric characteristic. So this could be whatever you need to define for it. In this case, it'll be our flatness tolerance. And there we go. And from there, you often add in a datum tag from that. And it's the same process as defining the surface. And once you have that reference defined, you can change how the tag looks, where it's located, with or without an elbow. So again, the whole process is meant to be, as you can see, fast and easy. And you can just keep moving on to whatever other parts of the model you need to work with there. All right, from here we can go ahead and look at our second annotation set here. Maybe we want to work with a dimension around the center bore. And that's what you can see here. We have some of these different annotations and dimensions all grouped together around particular features in this case. So that's what I want to do, is work around some of these holes that we have going through our gripper link. Start in by adding in a tolerance to that value. We can go through and show a plus minus for that range, and you could set those values to whatever you might need there. And now from that point, we can go ahead and add in our geometric tolerance right on top of that dimension. In this case, it's going to be for a perpendicularity. So one thing that you'll notice here is that right now, it's not giving us any type of guidance or validation that what we're doing is correct, because this is just using the standard out of the box Creo tools. Still able to give you all the capabilities that you need to lay those out, but still up to you, the user, to go through and define all of this. So very powerful, but still does rely on the user to go through and lay these out. And again, very often in this process, you might need to work with symbols. So you can see here, we can add in our diameter symbol. Very easy to go through and access that from the library of symbols that we have. We can add in multiple different symbols like our max material condition if we need to. And our GTOL block updates automatically for us. All right, so easy to work with from there. And just as we did before, we'll also add in a datum tag. For this one, we'll go ahead and pin it on the width line. And we can also add in certain surfaces that we want to reference with that datum. And with that, we're good to keep moving on. So from there, we can go ahead and work with some of the definitions around our mounted holes on the outside. So we'll start first and foremost by getting our diameter dimension here, dragging that away from the model. And just like we did with the other hole, we can lay out a range for that value. We can even define exactly how many decimal places should be displayed on that as well. And we can go through and make whatever additions that we might need to for those tolerances. So for example, here, since we have 4 of these holes, you can actually show that in your call out. You can type that in right there. So the process is very much painless. You're able to go through, add in your tolerances. In this case, it'll be a positional call out that we need to set here. And it's the same process as before. Go through, set any of the values that you need to. You can check your references related to this as well. So in this case, it'll be having a secondary reference for datum B. And in addition to all these different capabilities, you have the ability to add in additional text to any of the sides of the call out for any additional information that you might need to add in here. So say, for example, we need our person on the shop floor to know that this is referencing all 4 of those internal surfaces. You could lay that out here. And also clicking in, defining that on the Creo model itself as references. So the callouts aren't just numbers and letters. It really is true intelligence built into the tool as well there. All right, so good to go in that area. Go ahead and move on to our last annotation set. So like I mentioned, this process works well with any annotations that you had previously laid out. So we could do this for dimensions as well. So for this particular surface, I need to set a perpendicularity with reference to datum A. We'll go ahead and define that. And one thing that the tool is able to do as well is maintain any of the text that you added from before. So if you needed to carry that through for one of the surfaces to the next, you can go ahead and have that keep there. Or if you didn't want to, you could have it removed, either way that you want to have it laid out. So it makes it easy to repeat some of the callouts if you need to. And from here, we can go through and see some of the options that we have for building out dimensions here on the model. So very quick to go through and define what you need there from different surfaces. Very quick to lay these out for an amount of decimal places, along with exactly what surfaces that you want to reference. So maybe in this case, it's going to be our max dimension from one side to the next. Easy to lay that out as well. And just like that, and similar to what we did with the prefix, we can add in a suffix to that value saying that this is going to be a reference. All right, so just some quick work there. Again, very easy to go through and lay out any of that on the model. So once you have all that added in, you can go ahead and update your annotations. And then from there, save off the model however you might need to. So you can save the model off into a number of different file types. There's a couple different options that you have for step files. We have one specific called the step AP242. And what this is going to do is give you a step file that has all of these 3D annotation information added in here as well. So you can go through and decide exactly what you want to include with that. And once you save it off, it's ready to be used downstream for whatever purpose is necessary. So you can share it off with your shop floor, someone else that might want to pull that up over in Creo View, for example, view the annotations and go through and do the manufacturing there on the model as well. All right, any questions around that?
So one question that just popped in was, using annotate, how do I know if the annotations being added are semantic?
Yeah, so the semantic definition for any of those annotations is something that you could lay out. So that is something that I can touch on a little bit more towards the end of the presentation. I'll go ahead and provide a little bit more information on that as well.
Okay.
But yeah, definitely semantic definition is a pretty big aspect of what you're laying out for any of the annotations that you're doing in 3D space.
Good.
All right. So with that, again, more so just touching on some of the base capabilities that we had there with model-based definition. Again, one thing that you'll notice with that whole process is that it is up to me, the user, to go through and lay those out. And I do see we do have one question specific around the standards. So one thing with standards is that whenever you're working from within model-based definition, specifically in the normal Creo, it's not going through and being not abiding by certain standards that you've laid out. It'll essentially let you do what you want. So that's going to play into the next section of this here, where you're actually able to lay out the standards that you're working within and making sure that what we're laying out here is going to abide by those different annotations as well, or by those different standards, whether it be ASME or ISO, we keep up with those. So that is something that the GD&T Advisor specifically is built out to be able to do.
Okay, so I hope that answers John's question, because he was saying, is there any way to make sure that it meets the standard?
Mm-hmm. Yeah, exactly. So that is something that is built into the GD&T Advisor tool.
Okay, another question that popped in is, will the GD&T transfer to the drawing automatically?
So that's a very interesting question. And one thing that I'll say to that, first and foremost, is whenever you're building out geometric dimensions and tolerances, the idea is that you wouldn't have a drawing, right? The idea is that whoever you're sharing this out to, whether it be on the manufacturing floor, the shop floor, whatever it might be, that they're simply working with the model itself and being able to pull in all those annotations just right from the model. So you wouldn't have to have the secondary step of going through and building out a drawing to include all that information, because they're working with the model itself. Now, if you really needed to, you could simply just take screenshots of the model essentially in its different states to be able to see the different drawing annotations if you, for whatever reason, weren't able to see the model itself or weren't able to work with the step AP 242 or the Creo View file. But the idea essentially is that you wouldn't need to work with the drawing file, and that work is pretty much already done while you're going through and dimensioning the model.
So next question, are the dimensions driving the model?
No, it's the other way around. So essentially, the annotations that you're pulling up are driven by the dimensions. So more so the dimensions would drive the 3D annotations that you're going through and laying out there.
And next question, can we use these features on SolidWorks? So I'm wondering if they're asking if this GD&T extension works with SolidWorks.
You could go through, if you were to pull in a SolidWorks model and bring it into Creo, you'd be able to lay out annotations on it. Whether or not those annotated features would pass over into the SolidWorks environment, it would depend on SolidWorks' ability to work with Step AP 242. But if you were going to work with non-native data, we do have methods of bringing that in and being able to lay out model-based definition annotations on it as well.
Okay. Next question, do you have to export a step file every time to send it to the shop floor, or can they grab the file through Windchill? I like that question.
Yeah, either way. So it's completely up to you. If you have Windchill available, you'd be able to lay it out that way. And if not, you would simply just update the file and send it out from a file format perspective. But yes, you are able to simply grab the file from Windchill and actually do the visualizations through there as well.
Yeah, I think Windchill would be the way to go.
Mm-hmm.
That's just me. Not all vendors and customers are ready for model-based definition. Some require formal drawings per the contract. I think that's more of a statement.
Yeah, no, and it's a very true statement. It's definitely something that you have to be able to take into account. And in some instances, that's just, to be blunt, that's not something that you're going to be able to work around. So you can,
yeah,
it's an unfortunate reality of the aspect. It's definitely something that more so people are having formal requirements that include both around model-based definition and the 2D side of things. But I'd say in those particular instances, if you do have formal requirements on 2D drawings to be submitted for something like that, then you would simply just go through and have to do the 2D drawings for that. There's no really getting around that. So with those particular instances, I would say that that would be duplicate work that you would need to do. Some of the work that you went through and built out for the information can be transferred over into a drawing. So that work is still, I'd say, unfortunately needed to be duplicated if you do have specific requirements. But otherwise, you could, if you didn't have very formal requirements around model-based definition, just take screenshots of the different combination states and annotation states that you laid out. That would be another way to go through and do it.
Cool. So we're going to continue with the demo, and there are a couple of questions that we still need to answer, but we'll get to those at the end. But we'll continue with the demo at this point.
Sure, yeah, we can go ahead and take a look more so on the GD&T Advisor aspect, but we'll take a stop back later on after the demonstration and we can talk to some of those questions as well. All right, so this is going to go a little bit more outside of what we would have with just the standard capabilities, but really a very strong tool that we work with many times during this process of laying out model-based definition. So here we have another model that we're going to go through and lay out some annotations for. And the idea here is now that I want to work with our GD&T Advisor. So again, what we're doing with this tool, this is something that we built out with one of our partners, Sigmetrics, and we want to go through and provide you two main things here. So first and foremost is going to be education for working with GD&T on your models, and then also verification and validation that what you're laying out is correct. So it's just going to be another tool that you have access to, like you see right up in your applications. You can just go ahead and dive right into that. Just click of a button and you're going through and working. So here, I'm going to go through and show how this works. I'm going to start with our first surface up at the top here. We want to pick what we want to do. And whenever we select on the surface that we want to lay out, it's going to look a little bit different than what we had before. So for this particular surface, whereas before you had all the different options available to you, with the advisor, based on the standards that you're working on, in our case here, you can see the ASME standards that we're working with here laid out down in the bottom. what we have available to lay out here. And it'll give us recommendations on what you want to use here. So anything that's highlighted in green here is going to be recommended. And then if it has multiple recommended, it'll give you an asterisk next to it based on what's going to provide you the most amount of information based on the characteristic that you're applying. So with that, there's no guesswork. You just simply can take what you have, because then the system understands that the other ones would be invalid and knows what you need, and actually to define that, you can just go ahead and select on that, and then the system will be able to take that model or take that characteristic and build that into a data feature right there. And you can still do the same sorts of things like you were doing before. So if you needed to add in a tolerance range for one of these holes, you need to add in the upper and lower tolerance ranges. Go ahead and just lay that out here. And here we can see what type of characteristic we would have for that as well. So in this case, you have a little bit more available to you, but you can still see there that it's recommending us work with the perpendicularity characteristic. So that's the one we'll utilize. And with that, you'll go through and same sort of work as before, set the value, set whatever conditions that you might need with that. And then we'll simply take that and build another datum feature off of that. So that'll be our datum B. And once those annotations are built out, they work just like standard annotations. You can still go through and do everything that you would otherwise, but the advisor makes it so much faster and easier to get those built out. And just because you started in the advisor, you can still go back in and add in certain notes that you might need to. So it works both ways in that sense. All right, working on the next feature here on the side, we want to go through and define a diameter for that hole. Let's again define a range for that value. And when we look back in the conditions here, you can see what it gives us and what's available. And this one is recommending us the positional characteristic. And you can still use those other tolerances as long as they're valid, but otherwise we'll just use the one that the system recommends for us. All right, we can also build out multiple tolerances. So I could also, in this case, define the parallelism for that feature. That'll be in reference to datum A. And once we're done, we'll just click to run our GTOL. And now we can see that we actually have a composite GTOL. So not only fast and easy to build out, but most importantly, at the end of the day, accurate. That's what you need whenever you're doing this. Make sure that we're doing the right things. And we can keep building out another one over here. So we'll come over to the left-hand side and begin to define the hole at the bottom here. For that one, we just need a positional tolerance. Give it a value. Change the reference, give it a specified range. And we don't need a new datum with that one. We'll just accept it as is, and then we'll go ahead and drag that box out so we can see it a little bit better. Let's zoom in here on one of these holes here. And one thing that we can know, obviously, this is a pattern, but also the system can recognize that it's a pattern. So we can apply whatever tolerance is necessary with that. And then here we can have a positional tolerance applied to all 8 of those surfaces here. All right, so we can just run that and it's going to apply it to each of those there. And once you do that, what you'll do more than likely is pull it out into a position that's easily able to be read. That gives your downstream users a bit more information there. So we can also type in any additional text that we might need. So we can state that this is being used in 2 different places. And after we finish that call out, what we can do is check over in the advisor tree on the left here. And you can see whether or not you're having any issues. So right now we actually do have an error that is throwing us. It's saying that we have a 0 value tolerance that's not allowed. Well, sure enough, I must have forgot to put in a certain tolerance there. So we can just open right back up into the options that we have for that. We'll just give a range for that value. Define what we need to. And once we accept that, we could see over in the advisor tree that it's all good to go now. We now have a valid dimension. The error message goes away. So the system's always checking for these sorts of things. It's making sure that you're including what you need to or constraining everything that you also need to. One thing that we could do to check our work while we're doing this is use this show high constrained state. And what this is doing here is highlighting the constrained state of the different surfaces that we have in the model. So anywhere in green, you can see the surfaces or features that are fully constrained. In gray, you can see any of the surfaces that are unconstrained. So it really helps me to further understand exactly where I'm at with the model. One thing that you could do here as well is over in the properties, you could have that model controlled by an overall note that you have laid out. So that would be then highlighted in blue. And we could also go through to see what this would look like here as well if we wanted to lay that out. Let's just give this a general profile here. Say this has a general profile of 0.002. And once we have that added in, it's going to be added into the notes up here in the top. And it's going to be applied to all the different service tiers here, which you would now see are constrained by a service profile in the note. All right, and once you're done working in the GD&T Advisor, one thing that you're able to see is that we keep all the callouts that we created, and we can get right back into modeling. So you could take anything that you have here, move things around, make these different features look exactly how you want them. So if something got built out incorrectly or just something that you didn't like, you can always go through and change the orientation. So fast and easy to get this looking the way that you want as well. All right, so as you can see, really the main idea with this tool is the fact that if you're just getting up to speed with model-based definition, you can really make sure that a lot of the work that you're doing there is going to be correct. Even if this is something that you've done for a long time, you can really ensure that everything you're adding into the model that you're doing from a GD&T perspective is all adhering by any of the standards and making sure that ultimately what you're getting out to the field and out to the shop floor is going to be accurate at the end of the day. All right, well, I can take a pause here to answer some questions potentially.
All right. So a couple questions like regarding to what I think what you just covered. How do you treat undimensioned features? Do block tolerances exist?
Yes, they do. So you can have that. I guess I need a little more clarification on exactly what you'd want to do for that, but you can have block tolerances essentially.
Okay. So if you want to, I guess, elaborate on that, we'll get that answered. Next question: can we have different or specify different tolerances to a dimension that's driven by a family table?
That's a very good question, actually. I would have to check back on that and confirm on that. I believe you'd be able to, but yeah, that's actually a very good question. I don't know. Yeah, I'll have to look into that.
Okay. Yeah, so we'll get back to you with an email with that question. So back to the block tolerances. The one that gave you an error on the block tolerance should apply.
And was that in reference to the error that it threw in the GD&T Advisor? I'm curious.
I'm going to see what the response is.
Yeah, so I think that the tolerance there would still apply, but it might be also due to the standard. I'm not sure whether or not the minimum max needs to be involved with that. That might have to be part of the tolerance itself, and maybe with the certain standard and with that particular characteristic, you need to have a min and max defined with that. But then that would just be defined in the same way that we did during the demo. So whether or not you're working in Creo or you're in the advisor, you just add in the min or max to that.
Okay. One person wrote, can 8x be parametric? Typing 8x is a horrible practice.
Yeah, no, that's just something that you could do. It's definitely something that would be parametric. It's just simply if you wanted to add in any additional text, you'd be able to. More or less, you would be able to go through and have that defined. So like I did in the model, you'd be able to have that reference to each of the individual surfaces. So it is actually both in that case. You're not just writing the 8x, it is actually going through and still having the individual tolerances applied, not only just writing the 8x in there as well. So it's doing both in that sense.
Okay. One person said they often have customer requirements to have deliverable drawings. Having to repeat work into the drawing from the 3D model is counter to how annotations have been shown in the past.
Interviewer. Yep. Yeah. And again, in those particular types of instances, if you have very strict customer requirements is on the deliverable of the drawings, that would simply be repeat work. So in those particular instances, that's definitely something where I would say continue working with the 2D drawings. There's not really much that you can do if you have specific 2D requirements that you have to go through and lay out, and just keep working with the 2D drawings. But again, that's something that I would then begin to question why those requirements are in place, right? So it's more and more that we see out in industry that requirements are starting to include model-based definition work.
Mm-hmm.
And any of the work that you could do outside of that is definitely good to cover with model-based definition. But yeah, in those types of instances, there's not really much that you can do besides give them what's required.
Okay. Is it expected that all dimensions are toleranced separately, or can you apply a standard tolerance to all dimensions for 2 and 3 place dimensions?
Yep. So like you saw, there's either ways to do that by a general profile, or you could go through and have specific tolerances applied to multiple different surfaces, for example. So you can do it in multiple different ways.
Cool. Here we go. So a question is, if you modify a SolidWorks file in Creo, I think this has to do with Unite technology.
Mm-hmm.
Creo can take authorship, and you are no longer able to modify the SolidWorks file in SolidWorks?
No, you can actually. So it works both ways, where if you go through and modify the SolidWorks file, there's two different ways that you would do it. Number one, if you did a file import, then that SolidWorks model becomes a Creo model, right? It's converted over, and now Creo is working with it just like any other import Creo geometry. The other way is if you did a file open and simply opened the SolidWorks model in the context of Creo. So it would maintain that SolidWorks status until you convert it over, becomes Creo, and then you make whatever changes that you might need to, whether it be flex modeling or parametric. But the idea with that as well, though, is that you could still work with it over on the SolidWorks side. And then say, for example, you did have changes happen to the SolidWorks file, you could actually still have those changes pushed through. So if you needed to make any changes that you need to over on the SolidWorks side, have those update, you're still able to have those changes pushed through to the Creo changes that you've gone through and made. Whether or not the changes that you made are still going to be valid based on what's changed, that can depend. But even though it's taking over authorship of the model, you still are able to make modifications over on the SolidWorks side of things.
Okay. Okay, so next question is, can GD&T Advisor be purchased as an add-on to existing licenses, or does it require elevating to a higher package within Creo, within the Creo suite?
Definitely doesn't. You can simply just work with the GD&T Advisor as is. One thing that I will mention is that there are two different levels of the GD&T Advisor. Let me see if I can pull up a quick visual so you can see what I mean by this. Let me go ahead and flick forward a little bit here. There we go. Cool. Yeah, so you can see that there is a basic and advanced version of this tool. It's a standalone tool. You don't have to go up to a higher level package necessarily to work with it, but you could see that there's two main licenses of it. Essentially, one difference would be if you wanted to do some of this GD&T work in the context of assembly models, then you'd be able to move up to the advanced to be able to do that. From there as well, one of the things that is the difference here is that if you wanted to work with 3D annotations that were done before entering into the GD&T Advisor tool, then that would be essentially what you would do with the advanced. So that's for a particular type of case where you have models that were all fully dimensioned and toleranced, and then you want to go through and use the GD&T Advisor later on after the fact to go back and retroactively see anything that was non-compliant, essentially. So that would be another area that you could play into if you wanted to have models that were all defined using 3D annotations outside of the advisor, and then have the advisor check all of those annotations. Then it's able to do that, but it would just require the advanced license to be able to do that. So those are the main two differences, essentially, that you would have.
Cool. See, we're getting through these. Can the advisor do projected tolerances? This is usually for threaded bolt holes, flange and flange connections.
I'm not sure into projected tolerances. I'd have to check back on that one.
Okay.
Let me go ahead. I'll note that down here.
Okay. We will get. I will send you an email on that.
Okay.
I think this is the last one. If you change the dimension tolerance in a Creo drawing, my assumption is it transfers back to the 3D model. Thus, any annotations in the 3D model can be shown when detailing a part.
Yeah, so that is essentially how it works. So more or less what you're doing with those annotations in 3D is essentially showing what's defining it. So if you were to go through and change a certain tolerance or something that defines that feature, it would be able to be retroactively shown in a 3D annotation.
Cool. Can the advisor calculate required tolerances based on the assembly model?
No, so that would not be a capability. That would be something that you would simply go through and still lay out. It would be able to tell you what's required for a particular surface, but it's not going to go through and tell you exactly what tolerances that you would need to lay out, for example, on a model.
Okay. So I think the other question that's still open right now is regarding using annotate, knowing if the annotations are being added are semantic. I didn't know if you wanted to go back into that now.
Yeah, so this is kind of a particular area that goes a little bit deeper. I can pull up a quick area. So I can put this into the chat. So there's a tool called the semantic query, essentially, it's going to do this for you. So it understands how these different references work in the context of the model. So you'd use the semantic query to understand the different references and goes a little bit deeper into this. So I can also post this in the chat if you're interested in how this works semantically. So I'm not sure if that's something that am I able to post to the chat here? I'm not sure.
I don't see why you can't.
I think I'm only able to post to you guys, but I'll post it in here if you want to repost it to the chat, Rob.
Okay.
Yep, so this will give you a little bit more in-depth breakdown into how that tool works, but this is essentially how you would go through and work with that. And I'll put one last guide in here that would be able to talk to this. This is a blog post by Dave Martin, very strong Creo user, that goes a little bit more to how semantic references work in model-based definition. So these are two really good pieces of reading that would give you a little bit more information into that.
Okay. Okay. I'll send this to everybody. Boom. Hope that I got. Hang on. I may have messed it up. I think what it may have done is came through as one long link instead of two links. What just happened? I apologize for that. Try this again. I'm gonna do this one at a time then. Sorry, everybody. Do this and I think it's sent. It looks I hit enter, so I'm hoping everybody got it.
Yeah, I think we got it.
Yeah, I think everybody. So it's in there a couple times. So anyway, I apologize for that because it's not really. There we go. Now it's showing me what went through. The second time it went through again is 2 messages. I was trying to get it through singularly, and I think for some reason it sent your top message twice instead of the top message once, the top link once, and the bottom link a second time.
Gotcha.
Yeah, I'm not a fan of Zoom. There we go. So there's the second one.
Yeah, all and right. I do see one other kind of query here. So around Michael Uhelke's question around, I believe the understanding of what tolerances would be necessary. Wouldn't the easy tolerance analysis tool be what he would need? It's a little bit different. So essentially what the easy tolerance analysis tool would allow you to do is evaluate the impact of the tolerances that you laid out. So it won't necessarily tell you and analyze the model and tell you exactly what you need to lay out. But if you did go through and lay those out, it would allow you to see the impact in terms of the manufacturing defects of what you went through and did from a tolerance perspective. There's certain tolerances that works with, but yes, it would definitely still aid in that process. You'd be able to see, get a better look into the manufacturability of the model, but not necessarily to let you know whether or not you would be fitting under certain standards or requirements that you might have for GTOLs, for example. But yeah, it could definitely still help in that process.
Excellent. Well, we are well over. The questions just keep coming in. I was wanting it to do a tolerance study. Okay.
Yeah, so tolerance study would be more so covered under the easy tolerance analysis tool. So you would be able to look at the impact of your tolerances based on what you laid out. That would be more so, yes, get covered under the easy tolerance analysis tool, which again still does work with model-based definition work as well.
Excellent. So we did go over our expected time today, which is not necessarily a bad thing. A lot of good questions, great interaction. I hope that you guys got a lot of value out of this webinar today. So next week, we're going to have our webinar regarding Creo surfacing. So we'll take a look at surfacing tools within Creo, what's available within the base package with Freestyle, as well as the interactive surface design extension. If there's any other questions that you have or think of, or if you want to see more of a customized demo on model-based, any of the model-based definition tools, you could just respond to me from the email invitation that was sent to you. Those emails come directly to me. And we've been more happy to set that up for you. If you want to reach out to us another way, you can email us at info@3hti.com. And we'd be more than happy to help you out. So thanks again, everyone, for being on. And I want to thank Paul for doing a tremendous job and everything he did answering our questions. And being on it, and any questions that we did not answer that we said we would get you an answer on, you will receive an email from me regarding those questions. So thanks again, everyone, and have a great day. We'll have this uploaded onto YouTube, and we'll be sending you the recording of this webinar with the whole Q&A session. So that will look out for that tomorrow. Thanks, everyone.